Okay, anyway, so what I was saying before is we learned about present value, and remember present value is not necessarily, I don't want you to look at a point in time to decide whether to use present value or future value. I want you to think about whether or not we're including interest or not. So I know I've said this before, but I want to say it again. Future value already includes interest. And present value is before interest. So you'll be discussing interest either way. It's just that future value, the interest has already been added to be included in that quantity, and present value would be the amount before interest started accumulating. All right, so we looked at present value last time. So what about if you want to know the payment of a present value situation? So if you want to know the payment, and you know the present value, that's where the amortization formula comes in. So when you purchase a house, for instance, you will get an amortization schedule, which just shows you what every payment is doing to the principal or the amount that you owe for that loan. It is a paper that most people just put away in a file somewhere, but you actually should take a look at it. Okay? But here's the formula for payment when you know the present value. It's interest times present value over 1 minus 1 plus the interest, and then to the negative n power. Okay, so just like the payment formula involving future value was just a reworking of the future value formula, this is just a reworking of the present value formula. Okay, we're just solving for payment rather than solving for present value. Okay, so let's just verbally go over it. What is N? Always. Number of what? Number of payments total, right? M, like Mark, is the number of payments per year, right? But N is number of payments per year times the number of years. What about I? It's not just the rate. It's the rate over the what?
Over the how many times a year?
Over how many times a year. Okay, so interest is, or I is the rate over the number of times per year. Okay. All right, so let's look at an example. So let's say I asked you to find the payment for a $20,000 loan. If interest is 4% compounded monthly for 6 years. By the way, of the two payment formulas, this is the one I think that is most applicable to like everyday life, right? This would be like you want to go get a car loan for $20,000 for 6 years and you want to know what your payment should be. Maybe you don't want to trust what the dealership tells you your payment should be. You actually want to know what it should be, okay? So notice we are trying to find the payment, right? Which means we're definitely using one of our two payment formulas, right? We have two, one that involves future value and one that involves present value, okay? We need to know that it's a $20,000 loan. Okay, so before we move forward, would this $20,000 loan include interest or not? This doesn't include interest, right? Like this is what you're borrowing. It hasn't had interest added to it yet, okay? So the reality is you're going to pay what compared to the $20,000 if you take this loan? You're going to pay more, right? Because you're going to pay the $20,000 plus whatever interest you have to pay. And then we'll underline monthly because that's kind of significant too, okay? So we're going to use the previous formula, right? And so we're going to use payment equals I times present value over 1 minus 1 plus I to the negative n power. And off to the side, let's figure out what I is. Okay, I is going to be 0.04 over what? 12. And then N is going to be 12 times a year for 6 years for a total of how many payments? 72 payments, right? So it's going to be payment equals, and then you're going to have your fraction, your interest fraction, times 20,000. On the bottom, you're going to have 1 minus parentheses 1 plus that same fraction raised to the negative 72 power. So kind of like we've done everywhere else, okay, what do we need to insert / add in here? Parentheses, right? Parentheses around the top is not as important, just to be honest. And then definitely it is required around the bottom. Okay? It wouldn't be a deal breaker if you didn't put them around the top. It would be a deal breaker if you didn't put them around the bottom. Okay? It wouldn't end up working out. All right, so if you have a calculator, try to do this with me. So it's going to be parentheses, right? 0.04 over 12 times the 20,000. And then divided by open parentheses, 1 minus open parentheses again, right? For the 1 plus 0.04 divided by 12. And then raise that to the negative 72 power. And then close the parentheses overall. Okay? So if you push enter and we round it to the nearest penny, it would be $312.90. Okay, that seems like a reasonable payment, right? And the reason it's maybe smaller, like say this is a car loan. The reason that's kind of a small car loan is because A, that's a pretty low loan amount, right, compared to what new vehicles cost right now. And 4% is a decent car interest rate also, so keep that in mind. So I want to show you what would happen if you forgot the parentheses specifically around the bottom. So I did second enter, and I'm going to go delete those parentheses. So if you don't do what you're supposed to, you get an answer that I don't think seems reasonable. Okay, a $65 payment on a $20,000 loan. I mean, I know some of you don't have a lot of experience with finance, but that's too low, right? It doesn't make sense. So if you get an answer that seems crazy high or crazy low, it's probably because you made a calculator error of some sort. And most of the time, the calculator error you're making is not the right number of parentheses, or maybe opening a parentheses that you forget to close or something like that. Okay. So notice some errors the calculator catches, but this wasn't really an error according to the calculator, right? It's doing what it thinks we want it to do. And just so you know, what it's doing is rather than dividing the top by the whole denominator, it's just dividing the top by 1. And then it's going on and doing the rest of the stuff after that. Okay, so it's not doing what we want, but frankly, it's doing what I'm telling it to do. Okay, so if you want it to divide by that entire denominator, you must use a parentheses there. Okay. All right, so let's also figure out the interest amount. Because remember, I told you I was going to want you to be able to do that. Okay, and remember, the interest is always the difference between what we paid versus what we had / in this case, what we borrowed, right? So what's going to be more, what we pay or what we borrowed? This time it's going to be what we pay, right? That's going to be more, okay? So if we want to know what the interest is, we need to figure out our $312.90 payment times 72, and then we need to take off the actual amount of the loan, which was $20,000. Okay, so somebody work this out for me, the $312.90 times 72, and tell me what you get. You're saying the difference, but so I wanted this amount. So you mean it's 22,080? Okay. So notice this is the amount that we contributed, right? Or paid. And this is the loan amount. And so the difference between the two will be the amount we paid in interest, which is $2,528.80. So this amount is how much extra we're going to pay for that loan. Okay, so before we look at another example, when would that interest be more than that? There's a couple of different ways. When would that interest quantity be higher?
If it's compounded more often,
If it's compounded more often, that's one way.
if the interest rate is higher.
If the interest rate is higher, that's the second way. There's a third way too. If you borrowed the money for what?
A longer.
Longer period of time. Okay, all three of those things would make your interest rate increase, which means if you don't want to pay as much interest, what should you do? You should seek out a lower interest rate, right? Now, you don't get to tell them, hey, I'm going to pay you 4%. Like, they don't do that, right? You have to actually find another loan willing to, or another lender willing to lend you money. But you do have control over how quickly you pay off that loan, right? So that is one way to save yourself some interest, is to try to pay the loan off early. Okay, so let's look at another problem. I'm trying to kind of vary the wording that you might see in these various types of questions, because I think that's really half the battle, is reading through the question and figuring out which formula to use based on what it's asking. So let's say you buy a computer for $2,500, but you're broke, so you want to make payments. And so interest will be 10% compounded monthly. So how much will payments be? If you pay it out over 48 months. And then the second question is, how much interest will you pay? All right, so one question it's asking is, how much will payments be? Okay, so that's the first thing we want to find, right? And then you need to determine what this amount is. Is this the future value, or is this the present value? So what's the question you kind of ask yourself? You don't worry about time period. You worry about, does it include what or not? Does it include interest or not? Okay, so that's my question. If you're buying a computer from Best Buy or something, and they say it's $2,500, does that price include interest or no? It doesn't, right? So this is the what instead of the future value. This is the present value, right? So note that we want to know payment. And we know present value. So when we have that scenario, we use the amortization formula. Because the amortization formula is the one that looks like payment equals that involves present value. Okay, so we're going to say, okay, payment equals, and then a fraction. And then like we usually do, let's work off what our interest and stuff is off to the side. So what is my interest going to be? 0.10 divided by 12. Notice that my compounding frequency is often monthly. The reason I do that is not really for any other reason than real life payments are usually how often? Monthly. So that's why I tend to gravitate towards monthly. But make sure you know the other frequencies as well. And then N will be 12. Actually, you don't even have to really do it, right? Because they already told you N, right? So if you have 48 months, then it's just 48. You also could say 12 times 4 years, right? But notice in this case, they really kind of already told you the number of payments. So let's plug it in. We've got 0.10 over 12 times 2,500 on top. On bottom, we'll have 1 minus 1 plus 0.10 over 12, and then to the negative 48 power. Okay, so let's punch it in. So 0.10 divided by 12 times 2,500 divided by 1 minus 1 plus 0.10 divided by 12 raised to the negative 48. Okay. So I got this answer. Okay. And so I am hoping on the test or the review or whatever that you think, yeah, that's not right, right? Like $2,500 paid out every month, that's too low, right? So what did I forget? I forgot my what? My parentheses, right? So if you forget, remember you can do second enter on your calculator and you can just go in and edit. I'm going to edit a parentheses there. When you insert something, you do have to push second insert. Okay, so I'm going to insert it on the bottom. You technically don't really need it on the top. So notice that you get 63 there. Okay. So maybe we're still not sure about that, so let's go ahead and make sure that we insert them around the top too. But in the end, that's a little more reasonable, I think. Okay, so notice. See how it didn't actually matter if I had them on the top. That's what I was saying. The top is not so important because we're really just doing the top first anyway. If you don't have parentheses around the bottom, you do the wrong thing first, is essentially what it is. You change the order of operations. So the payment is $63.51. 41, I mean. Okay. So let's figure out what the interest is. So the interest will be this $63.41 times 48, and then we're going to take off the 2,500. So let's figure out what 63.41 times 48 is. It is 3,043.68. So this 3,043.68 is the what? Yeah, it's the amount you paid. Okay, and then this, right, is the loan amount. And so the difference will be the interest that we paid. Okay, so if you subtract those out, you will get $543.68. You know, if you're unsure if your answer seems to be like too high or too small, you could just compare it to, you know, what would be the payment amount if I didn't have any interest at all, right? And then that might be a good way for you to compare it. So how would I do that? I'm not going to write it down. I'm just going to do it on my calculator. If someone was nice enough to loan me money for this this computer without charging me interest, how would you figure out what the payment is? Yeah, you would just do 2,500, right? And you would divide it by the $48 or $48, 48 months, okay? So notice, without interest, you'd be paying $52.08. So 63.41 is, you know, I think close enough to the $52.08, right? So you're paying an extra, essentially $11 and some cents every time you make a payment, right? Because you're borrowing that money as you go. Yes?
So I'm assuming it would make a difference if we had a different cent amount for our answer on interest?
So are you saying you held, basically, did you use the unrounded version of this? Is that what you're saying?
Yeah.
Yeah, so in that case, we talked about that before, but in that case, your answer is actually a little more accurate than mine. So no, I wouldn't, that would be perfectly fine. But just for ease and for, I mean, really just for ease, we're just figuring out whatever that payment was rounded to the nearest penny. Okay, so let's Let's do one more where you have to kind of try to figure out what we need to do. So let's say that you want to purchase a car that costs this amount. And let's say that the dealer offers you a couple of different financing options. So the dealer offers you 0% financing for 60 months. Or a $6,000 rebate if you pay it out over 60 months. At 6.2% interest. With payments made monthly. So I want you to find each payment and then choose the better option. Now, if it weren't for the rebate, which one would definitely be better?
0%.
Yeah, the 0% would definitely be better, right? The question is, does the rebate give us enough of a kind of boost so that paying interest is a better plan for us? Okay. All right, so let's look at, do what?
I think I'm jumping again. You're fixing it.
Oh. All right, so for the 0%, it's very simple, right? We actually just talked about this with the previous example, right? We would not need a formula to figure out the formula, or figure out the payment, if we aren't charged interest, right? We just need to take the $27,300 loan, right? And then we just need to divide it by what? 60, okay? And we won't punch that in, but you get a $455 payment. All right, so what about the 6.2%? Okay, so the first thing is you need to figure out which formula to use, okay? So we didn't really have to make that decision on the 0% one, so let's go back up to the top, right? We want to find the payment. We know that the car cost $27,300, okay? By the way, present value is the same thing as cash value / sticker price. If you see any of those terminologies, it means that's the price right now before what has been added, before interest has been added. So this is present value, so we are going to use that formula again, okay? So it's going to be payment equals, and then our fraction. So like we always do, let's figure out the interest. So it's going to be 0.062 over 12 for I, and then N we're given, right? N is 60. So let's go ahead and plug that in. So 0.062 over 12. So, but here's where you need to pay attention a little bit, right? I'm not actually going to borrow $27,300 because I got a what? I got a $6,000 rebate, right? So we're actually going to only borrow the difference between the two, okay? So I'm going to say over off to the side again, if I want my loan amount, I actually need to take the price minus the rebate, because that's kind of like a coupon. It's a really, really fancy coupon. So it's actually $21,300 that we're borrowing, okay, because we had a discount of $6,000. So let me write that down here so that we remember later on where we got that from. And then on the bottom it is 1 minus 1 plus 0.062 over 12. And then to the negative 60th power. And then this time we are not going to forget to insert our parentheses. So if you work this out, you will get a $413.77 payment. Okay. So by the way, this deal would be like almost impossible to find, just FYI, okay? I'm
No,
just trying to,
I've never seen that scenario before.
yeah. So, but a lot of times the rebates aren't available. They're maybe not this high, but a lot of times they don't give you the rebates if they give you 0%. Like you do have to actually choose between the two of them. So in this weird case, the $6,000 rebate, bless you, plan is actually better. So the people watching the video aren't going to probably hear your sneeze. They're just going to think I just said $6,000 bless you rebate, but whatever. Okay, but this is a really kind of air quotes hypothetical situation, right? So I'm not sure that I really think that would happen out in the real world, right? So what if I went a little step further and I asked you how much better it is?
So I guess like what I'm thinking, and I saw this on the homework, are we, just by looking at the monthly payment, we already know it's a better deal?
Not necessarily.
Plan it out.
Not necessarily. Not if we were paying interest on this amount, we would actually need to figure out the interest for both, but because this one involves no interest at all, that's why we can make just the general. That's why I'm actually asking this second question, which is how much better is it? So in the first one, right, we're paying how much? Like there's no question what we're paying in the 0% scenario. What are we paying? Yeah, $27,300. Okay, so this is the amount we're paying in the 0% option. So let's find the difference between that and what we pay if we do pay interest. So we actually need to multiply this times 60, right? Because there are 60 payments. So this is the 6.2% option with the rebate. And so if you work that out, you will get, I'm going to go ahead and write down what they both are. You'll get $27,300 minus, I think I get $24,826.20. And so the difference is $2,473.80. Okay. So to really tell for sure which one is better, it probably would be best for us to figure this how much better is it first. Okay, but it's actually quite a bit better. And the reason it's quite a bit better is because you're getting a $6,000 payment off of it. But notice, like, it's not $6,000 better, right? They gave you $6,000 off the price, but you're actually only saving this much because the rest of that $6,000 got eaten away with what? With interest, right? So it's not as better as it could have been if there wouldn't have been the interest, obviously. Okay. Say again?
What would be a more realistic scenario since
A more realistic scenario would probably be like, honestly, for college students, you're not going to get 0%, just to be really, really honest with you. So that's a more realistic scenario. You usually have to have very established credit to get a 0% scenario. Also, often you have to be buying a really pretty higher level car. Not always, but you have to have been established in your, financial situation for a while. So probably they're not going to offer you that. And then, honestly, rebates are a little iffy. Okay, they offer rebates for lots of different things. So you can get rebates if you buy an older year model that just hasn't sold yet. Sometimes they'll give you a rebate if you're like ex-military. If you have already purchased that brand of car before and you're like a second-time buyer. I mean, there's all kinds of stuff they give rebates for. Yes?
So like what I've seen is they'll offer 0%, but then that'll be for the first 48 months or whatever.
Right.
And then, but they'll give you a loan for 60 months, and if you don't figure it out, like, and then it's.
Yeah, then you owe all of that at the end.
And then you have to do your own
Yeah.
calculation of, I'm gonna pay it off in the 48
Right. Even though they're telling me I only have to pay this amount, I better pay more so that I actually have it paid off. Yeah. I mean, they're there to make money. There's no question. So, and car salesmen have the reputation they do because they're not always on the up and up, right? So you always want to make sure you get everything in writing. Yes?
You also put down payment.
You could put a down payment. Yep.
You should.
Okay. Should. That's a really good point. Okay. So speaking of down payment, let's look at kind of a home loan situation. So I want to compare two scenarios. So, and again, some of you are, fairly young. You may not have purchased a home before. But I want us to compare two home loan scenarios. So let's say that you are purchasing a $150,000 house, and will pay, let's say, 5.2% interest for 30 years. Most home loans are typically 30 years. You can request less number of years if you want to. Okay. So let's say that option A is you pay no down payment. Okay, and options like that are appealing to consumers because they don't want to pay a down payment, right? But let's say that option B is you pay 10% down. And my question is, I want you to tell me how much interest will you save with option B versus A? Because it's kind of intuitive that you should pay less interest if you put money down, right? Because it means you're borrowing less money, right? So you definitely should save some money in interest. The question is how much? Okay, so let's run through the problem and kind of compare what we have, right? Yeah, I guess it's always going to be monthly for home loans. So let's say, let's add a little statement here, paying monthly. But yeah, I do need to be exact there. Okay, so notice you just need to ask yourself, I do need to find the payment, right? This quantity is the present value. Okay, right? It's the amount that doesn't include interest yet. Okay, so let's see if we can compare the two. So I'm going to maybe try to compare them side by side. So option A looks like this. The payment would be, the interest rate would be 0.52 over 12. We'll be borrowing $150,000 over 1 minus 1 plus. And by the way, I already made an error. What is it? It would be very unfortunate if I left this error. So what do y'all notice my error is? Yeah, 52% interest. Holy crap, you don't even want to know what the payment would be for that. It would be outrageous. So if you get something wrong on your calculator, you might also check your numbers and make sure you didn't do something goofy like I just almost did. Okay, but then it would be 1 plus that same fraction once we corrected it, right? And then what power would I raise it to? I didn't figure this off to the side just because I think we've done enough of these.
360.
Yeah, 360, right? Because it's 12 times a year times 30, okay? So this would be negative 360. Okay, so we'll punch this in just a minute. Just remember that we need to insert this and this, right? So before we punch it in the calculator, let's compare that to option B. So we're still trying to find the payment, right? That hasn't changed. Our interest rate is still 5.2%. Okay, but this time we're not going to be borrowing $150,000, right? Because yes?
Why is it 10 under the...
I don't know. Whew. That is a good question. That should have been 12. I don't know I can't even copy down numbers, right? I don't know what the deal is. So yes, good catch. We didn't punch it in yet, so that's good. All right, so let's figure out what our actual loan amount is, right? So how can we figure that out?
Get 10% of 150,000.
And then subtract it off of, right? So, or you could say, I'm only gonna borrow 90% of what I know the price to be, right? You could also do it that way. So either way, you're gonna get 135,000 here. Okay, so let's go ahead and make sure that we know where we got this from. This is $150,000 minus $15,000 for the down payment. Okay, so that's how I got that amount right there. Because 10%, remember, is easy to find. You just move the decimal place once. Okay, and then on the bottom, it should look the same as the other.
Will we get a crazy number if we forget the negative 360?
Yes.
So
Yes, you
we'll
will.
do that.
Um,
Something to do that.
yeah, you will get, so we'll look at that. Let's do the right thing and then we'll,
You'll get a negative number, since that's when we-
you won't get a negative number. You'll get a small, well, you might get a negative number. You'll get a really small number, whether that be a small decimal or possibly a negative number, yeah. So it kind of depends on how big the payment, how many payments there are. All right, so let's do the first one. So 0.052 divided by 12 times 150,000. Make sure and do the right number of zeros. And then divided by parentheses 1 minus 1 plus 0.052 divided by 12. Close parentheses, raised to the negative 360 power. Okay, so we end up getting payments that round to 823.67. Okay, so let's compare that with what we have here. So I am going to do the copy key because a lot of it's the same, right? In fact, I only need to change what? The 150 to 135, right? So I did second enter and then I used my arrows to kind of go over what I want to edit. And notice this time I can just kind of write it over. I just want to change the 150,000 to 135,000 and do a quick check, right? But that's all I wanted to change, so I think we're good there. Okay, so not surprisingly, this payment is smaller.
So where's the copy P? It's not, or the.
It's second enter,
Second.
and then it'll repeat the same thing that you did and allow you to make edits. It doesn't allow you to make edits once you've already kind of figured that out.
So it's not the second answer, but
Yeah, second answer is different. Second answer pulls in the previous answer that you got. So here are my two quantities, right? Obviously, the one with the down payment is a lesser payment, okay, because we aren't borrowing as much, right? So that's no surprise. But I asked you how much interest you'll save, so let's figure out the difference between the two. So I'm going to say the interest difference. So there's a couple of ways you can do this. I'm just going to do it kind of similarly to the way that we've always done it. So I'm going to do the payment of $823.67. So I want to kind of change this just a little bit. I want to change this interest amount to how much money will you save, because that's actually what I more want to see. So change this word. I know it seems like it might be the same, but I want to include what we had to pay on the down payment because that's actually important, okay? So if I ask you how much money would you save, we would do this payment times 360, right? And then minus what? So here's where we got to think about it a little bit. For the second plan, not only are we paying $741.30 times 360, right? But we also paid a down payment of $15,000. In other words, I can't act like I didn't have to come out of pocket for that, right? Because I did have to come up with that money. So let's compare the two here, right? So let's figure out what this one is first. So 823.67 times 360. Okay, this is 296,521.20. Okay, it is very common for home loans to be more than double what you thought you were paying because the interest is accruing for so long. It's accruing for 30 years. That's 3 decades of interest piling up and piling up. So it's a long time. All right, so let's do the second quantity. Okay, so by the way, this is option A. And then let's figure out what this one is. So 741.30 times 360. But then we do need to add in the 15,000 because we had to pay that too, right? For a total of $281,868 even. And of course, this is option B. So the difference would be what we would save, right? So we would take the $296,521.20 minus the $281,868. Okay, and so the difference is $14,653.20. Okay, that's the true difference in how much they paid more for option A than they did option B. Okay, so some people are okay with this difference. Why do you think they're okay with it?
Because they pay less per
Well, actually, they're paying more per month.
They don't have to make a down payment.
Yeah, so some people just don't have 15,000 sitting around to do a down payment, right? So like if you need to purchase a house and you don't have the down payment, you might be okay with this difference spread out over 30 years, right? You might be okay paying a fraction of a bit more of a payment than you were here, right? So I'm just trying to be practical with you. Of course, this is better, but frankly, if you don't have the down payment, this is still doable, right? It's still around what rent would be for an apartment or something. Now, remember, in real world, this is not all you have to pay to own a home, right? What else do you have to pay? You have to pay taxes every year on it. You have to pay insurance on it. Okay. Yeah. Now, I'm not including like utilities because you would have to pay that if you were renting or if you owned a home, right? So I won't include that. But I mean, I'm just saying this is just the payment for you borrowing the money. Okay. That would not include other things. And often, frankly, when you purchase a house, they do put all of that together for you, where you just kind of pay ahead for insurance and taxes so that you don't have to pay the tax office at the end of the year and you don't have to pay the insurance company at the end of the year. Most home loans wrap all that up for you, but the actual payment amount just straight up without any of those things would be the $823.67.
Taxes and taxes are high, and so when you
Yeah.
go shopping, like.
And going up every year.
You're gonna buy and think about your monthly payments. It's
Yeah.
higher.
Yeah, my monthly taxes on my house have gone up every single year. So, and like, I don't even know why. Like, it's not like my house is better than it was when I bought it. It's not. But yeah, it goes up every year. Okay, so next week we are testing, so make sure you're kind of ready for that.